Hello everybody, hope you're well. I want to talk a wee bit about exercise 17.3 that you had to do. Now, the examples that we were doing in the previous exercises were all linear patterns, and these are non-linear patterns. Now, if you look at question 1 here, you can see here that for the first pattern, there's 2 bricks. For the second pattern, there are 6 bricks. And for the third pattern, you'll notice here that, for the third pattern, there's 3 by 3, and there's also 3 added on. For the fourth pattern, there's 4 by 4, and there's 4 added on. So there's actually a wee pattern taking place there. Now, if you were to look at that, when he asks you how many bricks are there in the pattern for 5, well, it'd be 5 by 5 with 5 added on. And if you were to write this mathematically, it would be 5 squared plus 5, which is 30. Now, for the sixth pattern, it would be 6 by 6 with 6 added on, which gives you 42. The seventh pattern, again, 7 squared plus 7, which would give you 56. And the ninth pattern would be 9 squared plus 9, which gives you 90. Now, the algebraic term for this would be for the nth term. Now, that comes up quite a lot in these types of problems, and they use the letter n to denote any number that you like. So the nth term would be n squared plus n. And you can try that out with different ones to see if it works, and you'll find that it does. So for the second pattern, it would be 2 squared plus 2, 3 squared plus 3, 4 squared plus 4, etc. Now for question 2, you'll see here that there's a different pattern this time. The first pattern it tells you is 3 squared minus 1, which is 9, take away 1, which is 8. Now, if you have a wee look now, I wonder if it's better if I zoom in here. I don't know, I think that's probably better there. So, for question 2, can you see the pattern that's taking place? Well, what you'll notice is that every time you're adding on 1 to this column, and you're also adding on 1 to this column, so you're ending up with n plus 2 squared, where n is 1, take away n squared. This one here, for the second pattern, it would be n plus 2, which would be 4 squared, take away n squared, which would be 2. And again, if you then work out what that is, it tells you, the total number of blocks that it would require for each one of those. These aren't straightforward, it's a wee bit abstract, it takes a wee bit of practice to be able to do these, but hopefully when you play about with them, you'll begin to see the patterns and be able to work out the solutions to some of these problems. For the third one here, you're working with triangular numbers, so you've got 4 patterns that they give you. It's then asking you how many dots are needed for the next pattern, which is the 5th pattern. So you'd be adding on 5 at the bottom, because you'll notice that the bottom here, when you add the pool balls to me, or snooker balls, when you add the different row into the bottom, it's 1 more each time. So you're adding on 1 more for the 5th pattern, so you're adding on 5, then you'd be adding on 6, and so on. Now, to get the formula for that, it's a wee bit trickier. And you can see here, it gives you a clue. It says write down these values, what do you notice? And then you're able to see that you can come up with this formula here. So you've got a half times n times n plus 1. So you're adding on 1 each time. So for the first pattern, it would be 1 times 2, and then you half it. For the second pattern, it would be 2 times 3, and then you half it. For the third pattern, it would be 3 times 4, and then you half it. So if you were to write that down in terms of n, it would be n squared plus n, and then you half it. And the reason you would get to that is because you would have n times n plus 1 more, and then half it. And if you multiply out that bracket, you get n squared plus n, and then you're halving it. Okay, question number 4 is writing down the first 6 triangular numbers. Well, a triangular number is just this here, so you're starting off with 1, 3, 6, 10, you're adding on 1 more each time, so the next one you're adding on 5 to become 15, the next one is going to be 21, the next one would be, well, it doesn't ask you for that, but it would be, you know, you'd be adding on 7 that time to get you to 28, so you're adding on 1 more each time. Now, when you've got that there, just make sure you can see this. So when you've done that there, you've got your 6 triangular numbers, and then it says, show by drawing 4 diagrams that adding 2 consecutive triangular numbers gives a square number. Well, if you look at this here, you've got 1 plus 3, and that gives you 4, which is a square number. 3 plus 6 gives you 9, which is a square number. 6 plus 10, 16, square number. 10 plus 15 is 25, so a square number. A square number, of course, is one that square roots to give you a whole number. So the square root of 25 would give you 5, so that's why you know it's a square number. Now, for C, and it asks you to do, you know, I've done 2 of them here, so I did the next couple, but you could do more of them and play about with it as well. Which 2 consecutive triangular numbers would add together to give you 64? Well, if you continue on the list, which of them would give you 64? Well, just working your way up. 28 plus 36 would give you 64. 45 plus 55 would give you 100. And if you keep going, you would get to 66, and 78 gives you 144. So I hope that sheds some light on exercise 17.3. The other 2 exercises were a bit trickier again, and there was quite a lot involved in those. What I'm going to do is, rather than explaining them over a video, we'll be working through them in class. I'll maybe pick some of them as starters and you know, use them for maths challenges, etc. So I'll leave those there, and we'll revisit them, especially the more difficult ones. We'll revisit them in class, and we can explain them and talk about them more thoroughly. And we're going to move on tomorrow. Thank you. Bye-bye.